Hello everyone, in this video we discuss the solution of MCQ test paper of chapter 1 sets. So let's begin. Question number 1 is the number of elements in the power set PS of the set S is. We know that the number of power set of S is equal to the number of subset of S. Since the number of element S of S is 3, so the number of subset is equal to 2 power 3, which is equal to 8. Therefore the number of element in the power set PS is equal to 8. So option B is correct. And question number 2, let S be the infinite set and S1, S2, S3 and Sn be the sets such that S1 union S2 union S3 union ... Sn is equal to S. Then since S is the infinite set and S1, S2, S3, these are the subset of S, which union gives the Sn, which union give S. So there must be a subset of S is infinite, so that S is the infinite set. So the correct answer is C. In question number 3, if A be the finite set of the size n, the number of elements in the power set of A cross A. Since the number of element of A is equal to n, therefore the number of element of A cross A is equal to n into n, which is equal to n square. Therefore the number of subset of A cross A is equal to 2 power n square, which is equal to the number of element in the power set of A cross A. So the correct answer is B. Question number 4 is the total number of different partition of a set having 4 elements is. Since the number of element of a set A is 4, therefore the different partition means the number of subset, which is equal to the 2 power 4, that is equal to 16. So the option is A. In question number 5, the number of elements in the power set of the set A, B, C is. Since the number of element of the set is equal to 2, therefore the number of subset of the set is equal to 2 power 2 is equal to 4, and the number of subset of a set is equal to the number of element in the power set. So the number of power set of the set is 4. So the correct option is B. In the question number 6, in a language survey of the student, it is found that the 80 students know English, 60 know French, 50 know German, 30 know English and French, 20 know French and German, 50 know English and German, and 10 students know all the three languages. So how many students know at least one language? Let us consider that E is the set of the student who knows English, F is the set of the student who know the French, and G is the set of the student who know the German. So according to the question, the number of students who know the English is equal to 80, the number of the students who know French is equal to 60, the number of students who know the German is equal to 50, and the number of students who know the English and the French, the number of the students who know the English as well as French is equal to 30. Number of the students who know the French and German is 20. And the number of the students who know the English and the German is equal to 15. And the number of students who know all three languages means NE intersection F intersection G is equal to 10. We have to find the number of students who know at least one language. Actually, we have to find the number of students who know the English Union, French Union, German. And we know the formula of this. We write a number of students who know the English plus NF plus NG minus NE intersection F minus NF intersection G minus NE intersection G plus NE intersection F intersection G. Now putting the all values, we have N is 80 plus NF is 60 plus NG is 50 minus NE intersection F is 30 minus NF intersection G is 20 minus NE intersection G is 15 and NE intersection F intersection G is 10. So after simplify we get 135. So the correct option is A. In question number 7, in a group of 60 people, 27 like cold drinks and 42 likes hot drinks, and each person like at least one of the two drinks. How many like both coffee and the tea? Let us consider C the set of the people who likes cold drink and H is the set of the people who likes hot drinks. So actually we have to find out the NC intersection H, and we know that the NC union H is equal to NC plus NH minus NC intersection H. Now putting the value, we get 60 is equal to the number of people who likes cold drink is 27 and the number of people who likes hot drink is 42. Therefore minus NC intersection H. So we have NC intersection H is equal to 27 plus 42 minus 60, which is equal to 69 minus 60, that is equal to 9. So the correct option is D. This question also can be done by Venn diagram. So let us see. Now suppose these two circles represent two sets C and H, and suppose the number of X people like both coffee and tea. So we put in this overlapping area X. So the number of people who like only cold drink is 27 minus X, and the number of people who like only hot drinks is 42 minus X. And according to the question, the sum of all these numbers should be equal to the 60. So 27 minus X plus 42 minus X is equal to 60. X is cancelled out and 69 minus X is equal to 60. Therefore X is equal to 69 minus 60, which is equal to 9. So the correct option is D. In question number 8, there are 230 students, 80 play football, 42 play soccer and 12 play rugby. 32 play exactly 2 sports and 4 play all 3. How many students play none? So in order to find how many play none, first we find how many students play at least one sports. So let us consider the F is the set of the student who play football, S is the set of the student who play soccer, and the R is the set of the student who play rugby. So according to the question, the number of students who play football is 80. The number of students who play soccer is 42. And the number of students who play rugby is 12. Number of students who play all three sports means an F intersection S intersection R is equal to 4. The number of students who play football and soccer is F intersection S. But the number of the students who play exactly football and soccer is N F intersection S minus 4, because the 4 is common in all three. So similarly, the number of students who play soccer and rugby, exactly play soccer and rugby, is N S intersection R minus 4, and the number of students who play football and rugby is N F intersection R minus 4. So according to the question, the number of students who play exactly two sports is 32 given. So N F intersection S minus 4 plus N S intersection R minus 4 plus N F intersection R minus 4, which is equal to 32. Therefore, N F intersection S plus N S intersection R plus N F intersection R is equal to 32 plus 4 plus 4 plus 4, which is equal to 44. Therefore, the number of students who play at least one sport is N F union S union R, which is equal to N F plus N S plus N R minus N F intersection S minus N S intersection R minus N F intersection R plus N F intersection S intersection R. Now putting the value of these all, we have N F union S union R is equal to 80 plus 42 plus 12 minus within bracket N F intersection S plus N S intersection R plus N F intersection R minus 4. In the value of this bracket, we have already calculated 44. So we have 80 plus 42 plus 12 minus 44 minus 4. Actually this is plus, this should be plus. After simplify, we get 94. This is the number of students who play at least one sports. Therefore, the number of students who play none is equal to 230, because the total number of students is 230 minus 94 is equal to 136. So the correct option is B. Question number 9 is, in a class of 40 students, 12 enrolled for both English and German, 22 enrolled for the German. If the student of the class enrolled for at least one of the two subjects, then how many students enrolled for only English and not German? Let us consider E the set of the number of students who enrolled for the English, and the G is the set of number of students who enrolled for the German. Since the student of the class enrolled for at least one of the two subjects, therefore number of E union G is given, which is equal to 40. And the number of E intersection G is equal to 12. Number of students who enrolled for the German is equal to 22. Therefore, using the formula N E union G is equal to NE plus NG minus NE intersection G. Now putting the value of NE union G is 40 is equal to NE we have to find out plus NG 22 minus 12. Therefore, NE is equal to 40 plus 12 minus 22, which is equal to 30. But we have to find the number of students who enrolled for only English, not for German. So we have to actually find an E intersection G complement, which is equal to NE minus N E intersection G. Therefore, 30 minus E intersection G is 12, which is equal to 18. So the number of students who enrolled for English, not German, is 18. So the option is C. Question number 10 is, if A and B are sets and A union B is equal to A intersection B, then what is the correct we have to find from this? Let X belong to A. Therefore, X must belong to A union B. Since A union B is equal to A intersection B, therefore X belong to A intersection B. This implies that X belong to A and X belong to B. Means X belong to B. Therefore, A is the subset of B. This is the equation 1. Similarly, if Y is element of B, then Y must be element of A union B. Since A union B is equal to A intersection B, therefore Y is the element of A intersection B. Therefore, Y is the element of A. This implies that B is the subset of A. Therefore, from 1 and 2, A is equal to B. Therefore, the correct option is C.